In this video, we will be studying the first chapter of 10th standard syllabus, that is real numbers. Before starting the actual syllabus, let us recall what we have learned about the numbers in previous classes. So, number system. In number system, you have studied already what are whole numbers, natural numbers, rational numbers, irrational numbers and all. Let us study those all in detail. So real numbers, it is one family. It is a family of numbers. So let us take one simple example to understand this number system. So real numbers, let us consider one house is there. Its name is real numbers. Okay, this is one house or one family. In this one, two parts are there. One part we will consider as rational numbers and other part we will consider as irrational numbers. So, or else this family contains the members of that family. And here we will be having some pets, buffalo, ox or parrots like that. So, here in real numbers, this one, it consists of first rational numbers. Okay, like rational numbers means our grandparents. We'll consider like that. So these are rational numbers. Next is set of integers. So these are our parents, integers. Next is whole numbers. Whole numbers means I am the whole number here. Next, my sibling or my chota bhaiya or bhai. Then this is natural numbers, set of natural numbers. So these are all family members. Next here, irrational numbers. Irrational numbers, as I have told, it is family of pets and all animals. So this together, that is a set of rational numbers and irrational numbers, together it becomes family of real numbers. So real numbers is nothing but it consists of rational numbers and irrational numbers. So in most of the competitive exams, you will get one question on this. Sometimes what happens, 1 mark question, they will ask whether all integers are all integers are natural numbers or not, or rational number is a natural number. Such questions they will ask. To understand that, better I will take one simple example here. So let us consider the smallest set, that is set of natural numbers. It is also called as set of counting numbers. Here we will be having 1, 2, 3, so on. This is set of natural numbers. Then little bigger than this, that is set of whole numbers. Set of whole numbers. Here it consists of 0, 0, 1, 2, 3 and so on. So difference between natural number and whole number is here 0 is there. Now in natural number set and whole number set, only positive terms are there. Now let us consider negative terms. It will be little bigger than this. So let us call it as set of integers. Set of integers. It is denoted by Z. Here we will be having 0 as well as minus numbers, that is integers, negative as well as positive integers. Okay, next. So here we have considered 0 positive terms, negative terms. Next, little bit bigger to this, that is set of rational numbers. Set of rational numbers, it is denoted by Q. Here, what are rational numbers? They are in the form P by Q, where Q is not equal to 0 and P and Q are integers. So any of this set. So here why Q is not equal to 0? Suppose Q is equal to 0, then this becomes P by 0. that is infinity. It has no meaning. So here strict condition is q is not equal to 0. So just observe this. This is like a moving vehicle. It will go only in this direction. It will not come back in a reverse way. Means every natural number is a whole number. Every whole number is an integer. Every integer is rational number. But every rational number is not integer. Because if I take 1 by 2, it is a rational number. Is it an integer? No. So every rational number is not integer. Tell me whether every integer is whole number. See here. Suppose I take -2 here. Is it a whole number? No. Similarly, every whole number is not a natural number. Because if you take 0, it is not a natural number. In this way, just remember this chart. Okay? Only this is a small box. You can put it in the bigger box. But you cannot put a bigger box into the smaller box. That's why just remember this one. N, W, Z, Q. Only it will go in this way. If they ask objective type question, is every integer and is the whole number? Then it will come here. No. Every integer is a rational number? Yes. It is going like this. So just remember this one. Always, whenever in the competitive exams also, if question comes on this, easily you can answer. So this is about rational numbers. Then what is irrational number? Irrational number is not in the form of p by q, where q is not equal to 0. So how we decide whether it is rational or irrational? That depends on the decimal expansion of that number. Before that, let us take the whole number set and we'll check for in whole numbers how many types of numbers are there. So let us consider whole number set. We'll discuss about the whole number set. So as you know, whole numbers. So here in whole numbers, we have first one odd numbers, second even numbers, third one prime numbers, fourth one composite numbers. Why I am taking all these? Because if I started directly the real numbers chapter, it is difficult for you to understand. So now we are preparing the basic concepts. Basic concepts are clear, then easily you will understand the chapter. So here whole numbers means it is 0, 1, 2, 3, 4, 5, so on. Okay. So what is odd number? Odd number is a number which is not divisible by 2. Not divisible by 2. Such numbers are called as odd numbers. Let us consider 0. 0 by 2 is equal to 0. So it means 0 is divisible by 2. So 0 is not an odd number. Then consider 1. 1 by 2. Is it divisible by 2? No. So 1 is odd number. Next 2 is there. 2 by 2 is equal to 1. So it is divisible by 2. That's why it is not an odd number. Next 3. Is 3 divisible by 2? 3 by 2? No. So it is 3. Similarly 5. These are called as odd numbers. Next even number. Even number means which is divisible by 2. Divisible by 2. It is called as even number. Let us consider, just we have observed here. So 0 is a even number. Next is 2 by 2 is equal to 1. 2 is also even number. Next 4, 6 like that. Okay. What are prime numbers? Prime numbers means a number which is divisible by divisible by 1 and itself. 1 and itself. Such numbers are called as prime numbers. So, in prime numbers, how many factors will be there? 2 factors will be there. That is that number and 1. That number and 1. Let us consider 0. 0 is divisible by 0. Is it correct? It has no meaning. Okay, that's why it is not a prime number. Next, come to 1. 1 is divisible by 1. So it has only one factor. So it is not a prime number. Because what is the concept here? It should have 2 factors. So next, 2. 2 is divisible by 1 and that number itself. So 2 is a prime number. Next, 3. 3 is divisible by 1 and divisible by that number itself. Means it has 2 factors. So it is prime number 3. Next, 4 is there. What are the factors of 4? 1, 2 and 4. So it has 3 factors. Means more than 2. Then it is not a prime number. It is a composite number. It is a composite number. Composite number means it should have more than 2 factors. Then it is called as composite number. So 4 is a composite number. Next, 5. 5. What are the factors of 5? 1 and 5. Factors means it is divisible. This number is divisible by these 2. Then we say that these 2 are factors of this number. So it has only 2 factors. So it is a prime number and so on. Here 4, next will be 6 because it has 1, 2, 3 factors. So this is about odd numbers, even numbers, prime numbers and composite numbers. This concept is very, very important. Next, consecutive whole numbers means we write like this: 0, 1, 2, 3, 4, 5. It is consecutive whole numbers. Then consecutive even numbers means we write 1, 3, 5 and so on. And consecutive even numbers means 0, 2, 4, 6 and odd numbers means 1, 3, 5 and so on. This is important in studying this one. Composite number means you should understand it has more than 2 factors. So this is about real numbers, what are whole numbers and how many types of whole numbers are there in number system. Then comes the decimal expansion. That is also, you have studied all these in your 9th standard. Just I am recalling what you have studied. So decimal expansion, this is also very important. Decimal expansion. So when you divide a number by another number, you will be having, your answer will be, one is terminating expansion, that is terminating, means after division, after 2-3 times you will get, that is terminating. Second one, non-terminating, repeating. Third one, non-terminating, and non-repeating. Okay, so here terminating decimal means, for example, 0.2, 0.5, 0.8, these are all called as terminating. Means 0.2, it's over, division is over. You will be getting here 0 as the remainder. But here non-terminating means it is continuous, but repeating, question terms are repeating. Like for example, if I take 0.333, okay, So here just observe here, it is non-terminating, it is go on 0.333 like that, goes on continuously. Repeating means the same term is repeating here, 333. So we write this one as 0.3 bar. It means this is non-terminating repeating expansion because 3 is going to repeat. Similarly, you may get like this, 0.426, 426, 426. So it is not compulsory that only one term should repeat. Here 426, 426 it is repeating, but it is continuous. That's why it is called as non-terminating but repeating decimal expansion. Next is non-terminating and non-repeating. For example, root 2, 1.4132, so on. So just observe this one. It is non-terminating and non-repeating terms. All the terms are different. So root 2 and pi 3.142 and so on. This is also non-terminating and non-repeating. Then these two types, terminating, non-terminating, repeating, these are called as rational numbers. Rational numbers. And non-terminating, non-repeating, these are called as irrational numbers. Irrational numbers. Together these rational and irrational, it is real number set. So it is real numbers. We denote real numbers by R. We denote real numbers by R. So this is important. Terminating, non-terminating, repeating, non-terminating and non-repeating. This is about decimal expansion. Next is in this one, LCM and HCF. LCM means least common multiple, and HCF means highest common factor. Highest common factor. Okay. So here LCM. First we take one simple example and we'll find out LCM. Consider example. Find the LCM of 4 and 6 is there. Okay. Find the LCM of 4 and 6. What do you have to do? LCM means multiple, common, largest. We'll start with this. Multiple. Let us write down multiples of these two numbers. Multiples of 4. What are the multiples of 4? 4. 4 to the 8, 12, 16, 20 and so on. What are multiples of 6? 6, 18, 12, 18, 30, 36 and so on. Okay. So here next will be 24, 28, so on. Write down first is multiples. Next what is there? Common. What are common here? Common. Next 24. It is also common. Okay. So common are 12 and 24. Next we will get again. Then least. Next is least. Among these two, which is least? 12 is least. So LCM of 4 and 6. LCM of 4 and 6 is equal to 12. Is equal to 12. Next, what is HCF? So find the HCF of. Find the HCF. Let us consider say 4 and 6. So HCF means highest common factor. We'll start with this. First is factor. So 4. What are the factors of 4? 1, 2, 4. These are the factors of 4. What are the factors of 6? 1, 2, 3 and 6. Okay. These are factors of 6. Okay. We have written factors of 6. Next, what is there? Common. Which are common here? 1, 1 is common. 2, 2 is common. Okay. 2. Next, highest. Out of these two, which one is highest? 1 is common, 2 is common. Which one is highest? 2 is highest. So HCF of 4 and 6 is equal to 2. In this way, we find out LCM and HCF. Next, when we apply LCM and HCF, sometimes in problem statement examples, it is confusing whether we have to find out LCM or HCF. So, we will find out LCM and HCF by observing the question and what is the term there to find out LCM and HCF. So, LCM, HCF. In statement problems, sometimes we struck whether we have to find out LCM or HCF. So, some cases are there in LCM. If in the problem repetition word is there, repetition, then smallest or least, and next one cycling, or walking, running, such examples are there. Then also we use LCM, and when it happens at the same time, then also we use LCM. And HCF is used when sharing problem is there. Sharing, that is no remaining is 0. Then it is used largest, and when it is used split or divide equally, Next, fourth, grouping or arranging. Arranging your books in a rack. In such examples, we find out HCF. Here one simple example and many times they'll ask. One ground is there and A and B, two players are there. A will take 18 minutes to complete one round. Okay, and B will take 12 minutes to complete one round. So question is, when they will meet at one point on the ground. Then here question is of cycling, and when they will meet at one point happens at the same time. Then we find out its LCM. So 18 and 12 are there. Its LCM. Multiples are 36, 18, 36 and so on. What are multiples of 12? 12, 24, 36 and so on. So highest, it is multiple, common and least. Which one is the least common multiple? 36. So after 36 minutes they will meet at one point. So this is LCM problem. Next, HCF. Suppose one window is there. Here it is 15 meter and here it is 40 meter. I want to put grill like this. Okay. So, but these areas should be equal because it looks beautiful. Otherwise, it will look something like this. If you put one bigger, smaller, then it doesn't look good. So I want to make it little bit beautiful. For that one, at what distance I need to put a grid. In such cases, this should be divided equally. So that is divided equally. Then we consider HCF of these two numbers. So 15 is there. What are factors? HCF means factors. What are factors of 15? 1 is there, 3, 5, 15. Okay? And 40. What are factors of 40? 1, 2, 4, then 1, 2, 4, 5, 8, 20, 10, 40, 10, 40. Okay? If anything remaining, just note down. So, common factor, which is the common and highest. Which is the common and highest factor here? So, 1, 3, 5, and here also it is 5. It is common. Okay? Then HCF of 15 and 40 is equal to 5. So, what I will do? Here 5 meter, 5 meter. Here also 5. 1, 2, 3, 4, 5, 6, 7 and 8. In this way we divide this one equally. So here also I can make 8 parts of 5 meter each. Here I can make 3 parts of 5 meter each. So these are the applications of LCM and HCF. While solving the examples, it will be cleared again. But you should understand when it is applied. So this is about the basic concepts to understand the chapter real numbers. So thank you.